All right, so first of all, you know, I have put a review sheet on Brightspace about test number 2, which is going to be next Tuesday, right? So it's going to cover transformation of functions, right? Of course, this is a test, so you know, will I ask you like 10 transformation to do? No, of course not. 2 transformations, maximum 3. Okay, so. And then you will have algebra of functions, which is, you know, how to add functions, just like in the quiz. What is f plus g of something? What is f minus g of something? What is s times g? The composition of functions, etc., etc. Now, unfortunately, you know, on the test, no, on the quiz, I have encountered some people who think when you say f plus g of something, they think it is a multiplication. It is not a multiplication. It is not, right? At all. So you have to go back and review that, okay? And then you're gonna have the 4.1, which is the inverse, how to find the inverse of function. And that question also was in the quiz number 2, okay? A lot of people did that right, okay? Some questions like that, okay? And then the chapter 3 is quadratic functions, right? Quadratic functions, you know, how to find the vertex, etc. What is the maximum height? When do we get the maximum, etc., etc. Okay, and how to find the x-intercept, how to find y-intercept. Just, you know, regular quadratic equation, quadratic function. Okay, you know, and then something we're going to do today is how to graph polynomials using the zeros. Okay, that's it. 3.2. 3.1 is a quadratic function. 3.2 is, you know, graph of polynomials. And we studied last time, you know, we just talked about what was a zero. We introduced the concept of zero. So we're gonna continue on that, right? So let me share my screen. All right, so, okay, so everybody can see my screen. So we said last time, what was a zero for a polynomial? We said it last time, and the zero is any number that you plug in to get zero. A zero is also an x-intercept, right? And a zero and the factor and the factoring, the zeros and the factoring are very, very correlated, okay? So we did it last time. So, and what we said, particularly if you have two successive zeros, right? If you have 2 successive zeros, for instance, we said if A and B are 2 successive zeros, A, B are 2 successive zeros, right? And which means there is no other zero between them, right? You see, this is an x-intercept. This is an x-intercept. If there are 2 successive zeros, no other zero between them, we said last time, the graph cannot be like that, right? And we asked why. Why the graph cannot be like that? Do you recall what we said? Can somebody talk?
That means there is another zero between them.
Exactly. If the graph is like that, it's going to mean there is another zero between them. There is a new zero that was not here. This is a new zero right here, right? And if this is a zero, it means these two are not successive anymore, right? It means they are not successive anymore. So that is the reason if two zeros are successive, the graph will be either all above or either all under, if they are successive zeros, right? And we're going to use this very fact to graph some polynomials using zeros. Now, will the graph be perfect? Of course not, because if you want to truly graph functions, we have to wait until calculus, okay? But we can have the the shape of the graph. So for instance, graphing using zeros, we're going to do that. Graphing using zeros of a polynomial. Okay, so for instance, we say f of x equals x plus 3, x plus 1 times x plus 3 times x minus 3. You're going to try to graph this polynomial using the zeros, all right? First of all, we have to find the zeros. What are they? That's the first step. What are the zeros?
-1, -3, and +3.
Exactly. The zeros are -1, -3, and +3, right? Write them this way. Okay, everybody in this room understands where the zero come from? We just solved each factor to 0, right? We just set each factor to 0 and we solve. Okay, so now look. They are also x-intercept. Okay, my zeros are also x-intercept for the graph. Now I'm going to do this. Okay, something very important here. I elect not to put units on the y-axis. Why? Because if I put units on the y-axis, then you're going to see later that I can be stuck, because I truly don't have the real tools to graph my polynomial, right? The real tools, for instance, to know what are the local maxima, what are the local minima. I cannot know that until I do some calculus stuff, right? And we don't do calculus. So what I do is to put the units on the x-axis, I put the zeros. I have -1 is a 0, +3 is a 0, and -3 is a 0, right? Everyone follows me? Now look now, from what we just said before, between these two zeros, the graph is all like this or like this. Do you agree with that? Between -3 and 1 and -1, the graph will be all above the x-axis or all under the x-axis. How am I going to know that? Very simple. If you want to know where the graph is, if it is above the x-axis or below the x-axis, if you want to know that, you pick a test number. Okay? You're going to pick a test number. You see, if I pick, for instance, a test number, if I have a point on the graph which is here, if I have 1 point on the graph and the point is here, what's it going to mean? Where's my graph is then? My graph will be above or below?
Above.
Above. If I now, on the contrary, if I have a point which is here, I have a single point on the graph that I tested and that point is here. What's going to mean my graph? My graph will be all below, right? Everybody understands the logic we are trying to do? So we're going to pick test points, right? Very nice numbers that we're going to test. For instance, between -3 3 and negative 1, right? Between negative 3 and negative 1, if I want to know where the graph is, I pick a test number, which is negative 2. I know everybody's going to pick negative 2. Does it make sense to pick negative 1.7? I don't think it makes, you pick a very nice number between negative 3 and negative 1. Let me pick a negative 2, right? You see, negative 2 is not like as important as negative 3 or as negative 1 or as 3. Negative 3, negative 1, and 3 are the x-intercept. They are very, very important. Negative 2 is just a test number. It could have been negative 2.5. It could have been negative 1.5, 1.3. Just a number between negative 3 and negative 1, right? What I'm going to do, I'm going to plug in that number here. I'm going to find f of negative 2, right? Which is what? I'm going to plug in negative 2 everywhere. It's going to be negative 2 plus 1 times negative 2 plus 3 times negative 2 minus 3. I'm going to see how much this gives me. It's negative 1 times the negative 5, which is 5, right? 5 is positive. So I have a 1 point above here. You see? I have 1 point above. If I have 1 point above, it means what? My graph lies. So the graph lies above x-axis between negative 3 and negative 1, right? It means the graph lies above the x-axis between negative 3 and negative 1. Okay? Does it make sense, everybody?
Yeah.
Because I have 1 point which is above, right? If I have 1 point above, it means the graph lies above, right? Okay. Now, what is something I don't know? Can somebody tell me? I know the graph lies above, right? The x-axis, I know that. What is something I don't know yet? Can you tell me? I know the graph will be like this, you see? This is an x-intercept, the graph will be like this. What is something I don't know?
The vertex.
The vertex, okay. The vertex is reserved for quadratic, for parabolas. We're going to say the maximum, you see? Thank you very much. It's like the vertex. We don't know how far we go above. We don't know. Unfortunately, we have to do some calculus stuff to figure out exactly how far we have to go above, okay? But we don't focus on that, That is why I said the y-axis free of units, just to say, okay, I'm going to go this far. So in the test, we will not focus on how far you go above. We rather focus on, do you go above or do you go below? You understand that, everybody? You see, I don't know exactly how far I go above, but in this class, right now, we really cannot know how far we go above. We cannot know. We have to do some calculus, okay? Everybody understand what we did here? We plugged in negative 2 in the function. We find 5. That means my point negative to 5, which is, when 5 is positive, the point lies above the x-axis. If 1 point lies above the x-axis, all the other points, they also lie above the x-axis, right? Okay, now we're going to pick another test point between negative 1 and 3. The same question. Do my graph lie above the x-axis or do my graph lie below the x-axis, right? I don't anticipate anything until I check, okay? I don't anticipate anything until I check my answer, until I check. Okay, can you suggest to me a test number, which is a good test number? A good number between negative 1 and 3. Very simple number.
2.
2? Okay, we're going to pick 2, right? But we have simpler than 2. We have 0, we have 1, right? Well, we're going to pick 2, okay? You're going to find f of 2. F of 2 is 2 plus 1, 2 plus 3, and 2 minus 3, which is 3 times 5 times negative 1, which is negative, right? Since this is negative, the graph lies below. X-axis, right? The graph between negative 1 and 3, the graph lies below x-axis. Again, what I don't know again, How far we go below, that I don't know, you see? But I know the graph lies below. Everybody understand that? It's
So,
little math, you know, the math we are doing are very, very simple math, right? We're just plugging in numbers. And now after three, I'm going to pick another test number to know where the graph is. For instance, let me pick 4, right? As a test number to know if my graph will be like this or my graph will be like this, right? Okay. I pick 4. I said f of 4 is 4 plus 1, 4 plus 3, and 4 minus 3. How much is that? It's positive, right? It's 7. I mean, it's 5 times 7 times 1. This is positive. So it means the graph lies above. So my graph will be like this. Now, can you tell me why my graph does not bend again? Can you tell me that? Can you tell me after 3? After 3, can you tell me why my graph will not do that? Why?
Is it because there are no more zeros?
Thank you very much. Absolutely. Because there is no more zeros. If my graph does this, it's very probable it's going to do that, right? If it does that, it's going to introduce a new 0. But we don't have no more zeros, right? We don't have any more zeros. So my graph stops here. You see, my graph just keeps going up like this, right? And right now here, f of -3, right? After -3, I have -4 here, right? What is f of -4? It's going to be -4 plus 1, -4 plus 3, -4 minus 3. This is a negative number, negative number, negative number. When you put 3 negative, you get a negative number, right? So my graph lies below. So which means I'm going to keep going down like this. You see that? If you take a calculator, I will not tell you my graph will be accurate, right? Because there is nothing done here for accuracy. But the shape will be exactly the same shape. Okay? If you graph this one, you're gonna have the same shape. So all of you know, a graphing calculator, Wolfram Alpha. I mean, Desmos, right? This is a graphing calculator. So let me share my screen so you're gonna see my calculator. Okay, everybody sees the calculator right here? So if I say y equals x plus 1 times x plus 3 times x minus 3. Do you see that? Do you see? If I zoom out, do you see? Everybody see that?
Yes.
Yeah.
That looks exactly, does it look like the shape we have?
Yes.
Right? It does look like the shape. This is what I was talking about. So there is no accuracy in what we did because we don't know calculus, right? Particularly if you want to know what are these 2 points, this point right here, and this point right here, you absolutely need to do calculus. Absolutely. You have to do what is the derivative, etc., etc. We haven't done that, but that is why to bail me out, I say this is free of units, you see? My y-axis is free of units, just to bail me out, right? Okay. All right, so this is how we graph using the zeros. This is how we graph using zeros. Little calculation. There is almost no calculation, right? Almost none. So now how are you going to do that? X times x minus 4 squared. F of x So what are the zeros here? Try to do that. Try to do the zeros, right? And then try to see what you get, please. Okay. Find the zeros and then do the stuff, pick your test point and try to see what you get. Hi, everybody. So what are the two zeros here to begin with?
0 and 4.
The two zeros are 0 for this one and for this one. Do you remember what we said about, the multiplicities? So the 0 is a 0 of multiplicity, how much? The
1.
0 is a 0 of multiplicity?
1.
1, right? The 0 are this is, and the multiplicity right here. This is 1, and this is, what is the multiplicity here?
2.
2. Yeah, but 0 is a 0 of multiplicity 1, and 4 is a 0 of multiplicity 2, right? So we're going to see, does it make a difference when we graph, right? Does the multiplicity play a role when we graph? We're going to see that, okay? So, but we're going to do what we did. I hope that you guys did that. So we have our axis right here. I have a 0, so I'm going to put my x-intercept, which is 0 and 4. 1, 2, 3, 4. Okay, now look now. What test point did you get between 0 and 4? What test point did you get? Somebody tell me, what test point did you pick?
1.
You picked 1, right? So I get f of 1 is equal to 1 parentheses 1 minus 4 square, which is 1 times 9, which is positive, right? Where's the graph lies, above or below?
Above.
The graph lies above the x-axis, which means this. Okay? After 4, I'm going to pick another test number after 4. For instance, obviously, everybody going to pick what number? Just to make it easier. Everybody want to pick?
3.
After 4, right?
After 4, 5.
5, right? So you get f of 5 is equal to 5 parentheses 5 minus 4 all squared, which is 5 times 1, which is positive. Where the graph lies again? Above. You see, do not assume it's going to be above and then below and then above. It's case by case, right? Here we have 2 successive case where it lies above. So we're going to do this, right? Everybody see that? Okay. And then we said it does not bend. After 4, the graph will not bend because we don't have any more zeros, right? Or any more extremas. So, and then we have the last one here is we're going to pick -1, right? As a test number. Let's do f of -1. F of -1 is -1 parentheses -1 minus 4 square, which is -1 times 25, right? Which is negative. So the graph lies below. It's going to do like this. Okay? So now look now here. We have 2 x-intercepts. But do you see any difference of the behavior of the graph across the 2 x-intercepts? Across 0 and across 4, what do you see? Somebody tell me.
Graph rises and then falls.
Say again.
The graph rises and then falls. It's above the x-axis.
Exactly. So this is across 0, 4. In particular, the graph does not cross the x-axis, right? And across 0, the other x-intercept, the graph actually does cross the x-axis. Actually, there is a link between that behavior and the multiplicity. When the multiplicity is odd, the graph will cross the x-axis. When the multiplicity is even, like 2 over there, right, the graph will not cross the x-axis. The graph will touch it, but will not cross it. So this is even. The graph will not cross the x-axis. You see, we call this one a turning point. Or a touch point. Okay? We're gonna abbreviate with TP. TP means turning point or touch point. When the multiplicity is even, the graph will never cross the x-axis. When the multiplicity is even, the graph does not cross the x-axis, right? When the multiplicity is odd now, the graph will cross the x-axis. And we're going to call it CP, cross point, right? CP is a cross point, CP, okay? Cross point. The graph will cross the x-axis. If the multiplicity is odd, the graph does not cross the x-axis. If the multiplicity is even, the graph crosses the x-axis. For instance, if I have this graph right here, all right. How many zeros do you see here?
Five. I see 4.
4 zeros, 4 x-intercept, right? I see 4 zeros myself. I see this 0. I see this 0. I see this 0. I see this 0. Okay? All right. Why I put the 2 in red, 2 in blue? What is the multiplicity of those in red? How is the multiplicity of those in red?
Ones in red cross the x-axis and the
They
ones
cross the x-axis. So the multiplicity is how much? Even or odd?
odd.
This is a cross point. So this is a 0. This is a 0 of odd multiplicity, right? Which means the multiplicity can be 1, can be 3, can be 5, can be etc., right? This is a 0 of odd multiplicity. Okay? The 2 in blue, they are turning points, turning point, which means a 0 of even multiplicity, right? And this is 0 of even multiplicity. Okay? So now, something you can do is, you can use that. You can use that stuff, the fact something is cross point, turning point, cross point, turning point, to do the graph more quickly, to avoid testing. You see? All right. Let me show you how you're going to do that more quickly. You see the graph we just graphed before? F of x equal to x times x minus 4 squared, right? We're going to use the turning point, the fact it is a cross point or a turning point, to graph more quickly, okay? You see, what are the zeros? It says zeros is 0 and 4, right? What type of zeros are there? Is 0 a cross point or a turning point? It is a CP or a TP?
TP.
How much is the multiplicity of the 0,
P.
0? Look right here. What exponent you have here?
Point because it's odd.
Is 1, right? Is odd. This is odd. Since it is odd, so my 0 here is a cross point, which means across 0, when the graph comes across 0, is going to cross the x-axis, right? Okay, now how much is the 2? It is even, right? So which means this one is a turning point. This is a TP, right? How am I going to use that? Very simple. Look, this is how I'm going to use that. I'm going to see it's very, 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 very fast. I have 0, which is a cross point. I have 4, which is a turning point. Now, I have to do at least one test. Okay, I have to test one number. Okay, I cannot avoid testing one number. Let me test one. Well, but we just want to test one number, and then we're going to use the properties. I test one. F of 1 is 1 times 1 minus 4 squared, which is equal to 9 positive. So the graph lies above. You see, I'm going to do this. The graph lies above. Now, when I come here now, I don't want to test anymore. I'm going to use the property of turning point. Since 4 is a turning point, what's the graph going to do?
Going to rise.
The graph will turn, right? As the name says, is turning point means the graph will turn back where it came from. Everybody agree with that? I mean, I'm not talking to everybody. I think since the beginning of the class, maybe 2, 3 people are talking. I have like 18 people in the roster right here. I really hope, whether you are muting yourself or not, you understand what you're doing. If you don't understand, you have to say it, right? You see, when I ask those questions, I'm hoping for more participation. What the graph does is to turn, right? Is it turning point? This is a TP. Since it is a TP, it's going to turn away, right? Right here, it does not cross. It's going to turn, but very smoothly, right? The graph of polynomials, they cannot do that. They don't turn this way because this is a corner. They turn this way like this, very smoothly, right? Okay, so you see that what this makes me avoid? It made me avoid another testing, right? Okay, is it a good thing? Because when you test numbers, you can do mistakes, right?
Yeah.
When you use that, you cannot do mistakes. When you use the turning point stuff, you cannot do mistakes. Okay, now let's focus on the left side now. 0 is a cross point. Since it is a cross point, what's the graph going to do? What's the graph going to do across 0?
Cross.
It's going to cross the x-axis, right? It came from above, is going to cross the x-axis. Okay, because it's a cross point. And this also made me avoid another test. You see that? So using this, if you understand this concept, it makes your graphing very, very fast, because how many numbers you have to test? Only one number, right? You're just going to test only one number, and you're going to complete the rest by cross point, turning point, etc., right? But that is out. So now let me try to use the turning point, test point, f of x. All right, find the zeros right here and say what each zero is. What is the type of each zero? If it is a turning point or a cross point. And then please try to use that. Try to use that to graph. Because if you understand that way, it's way, way faster than testing the numbers. All right, I'm going to let you 5 minutes to do that, please. So if you get the zeros wrong, then for sure your answer will be wrong, right? So we have to have the right zeros. So I'm let you finish, right? All right, so what are the zeros?
I wasn't really sure how to solve the first factor, but I know that the other two are -2 and then +3.
Thank you very much. You know, the -2 for this one and +3 for this one. Okay, this one right here, I intentionally put the 5 here, but it doesn't change what's going to be the 0, whether it's 5 or another number. When you said 5x squared equals 0, you divide by 5, you divide by 5, you get x squared equals 0, which means x equals 0, right? Whether you have 5 or you have any other number, if you just multiply by x squared, it will not change. The 0 will be still 0, right? So still going to be 0. See, the 5 here does not play any role for the zeros, right? Okay, so now look at the multiplicities. Because this is 2, because this is even, right? What's going to be, what type of 0 is 0? A CP or a TP?
TP.
It's a TP.
It is a TP, thank you. It's a turning point. Because this is 1 is odd. What type of 0 is -2?
CP.
A CP. And because 2 is even,
TP.
this is a TP. How are we going to use that? You know, we're going to use this TP, CP stuff. It's going to save us a lot of, you know, lots of testings. Okay, so we have 0. It is a turning point. We have 3. Which is a turning point. And we have -2, which is a cross point. Okay, so now what number are you going to test? Any number. It just has to be, a nice number. So we don't struggle. 1. 1 is a good number to test with, right? So f of 1, which is 5 times 1 squared, parentheses 1 plus 2, parentheses 1 minus 3 squared. Actually, I really don't want exactly the number. I just want to know if the number is positive or negative, because anyway, I haven't put no units on the y-axis. You see, I haven't put no units on the y-axis, so I just want to know if the number is positive or negative. Okay, so 5 times 1, this is 5, this is positive. It's going to be 5 times 3, and this is -2 squared, which is 4. That is a positive number. Okay. So which means the graph lies above. Where one is at? Between what zeros? Where 1 is at? Between what zeros?
Between 0 and
3.
Between 0 and 3. So 1 is here. So what we said is above is the section of graph between the piece of graph between 0 and 3. Now we're going to use our, you see how fast it's going to go? Now we're going to use the property. 3 is a turning point. What's the graph going to do? Turn, right? 0 is a turning point. What's the graph going to do? Turn, right? And -2 is a cross point. The graph going to cross. That's it. If you don't go that way, how many numbers at least you have to test? Only 2?
3.
You have to test a total of 4 numbers. We did 1 of them. We have to test 3 more numbers, right? You see, if you don't go that way, you have to test 3 more numbers. Again, and again. What is the only thing here we cannot figure out? The only thing we can figure out is the maximum here. We cannot figure out these 2, okay? Until we do calculus. Do you have any questions about how to graph? You're going to see that on the test next week, okay? You're going to see that on the test next week. I understand the calculators are allowed, right? So you are allowed to use a calculator, but I have to see a minimum of work, okay? I have to see a minimum of work. I have to see the zeros. What are the zeros? I have to see what type of zeros are they? Turning point, cross point. I have to see at least 1 test number, okay? In the test, I have to see the zeros in the test. List zeros, right? List the type of zeros. At least 1 test number. Okay, if you want to get the points. If I just see a graph that looks like a good graph without all this information, you know, I said, okay, you picked it from the calculator, okay? So you don't get no credit. You agree on that? So it is a very, very little calculation. You see, when you look at this, it's almost no calculation, almost none, right? Okay, so that is graphing using the zeros. So now we have how many zeros a polynomial can have. A polynomial, if f of x, if degree of n, the degree of f is equal to n, then f has a maximum of n zeros, a maximum of n zeros. Maximum of n zeros, right? Okay, so for instance, right here, if I do this, how many zeros do you see for this graph?
3.
This graph has 3 zeros, right? 1 0, 2 zeros, 3 zeros. What can we say about the degree of this polynomial? I don't know what is the degree, right? What can we say about it? Is it bigger than 3, less than 3, or equal to 3?
Equal to 3.
Are we sure it is equal to 3?
Equal or less, I think.
Equal or bigger than 3 is at least equal
Oh
to 3.
yeah, at least. Oh yeah.
At least, you see, I don't know how much is the degree of this polynomial, but at least it's 3 or 4 or 5 or 6 or 7 or 8 or 9, right?
I have a question.
Yes.
How do you know that it's equal or greater than 3?
Because there's a theorem, this theorem right here says the number of zeros is to the maximum equal to the degree. Okay, so the number of zeros is less than number of zeros. Number of zeros is less than or equal to the degree. Right?
Okay, thank you.
That is the theorem right here. The number of zeros of a polynomial at the most is equal to the degree, at the most, right? So if this is three zeros, which is less than or equal to the degree, right? Which means the degree is at least 3 or 4 or 5 or 6 or 7 or 8 or 10, right? It couldn't be more than 3, but it cannot be less than 3, okay? If I do this right here, if I say f of x equal to 7x to the 6th minus 2x to the 5th plus x cubed minus 5 plus 5x plus 1. What is the maximum number of zeros of f?
6.
Alhamdulillah. Thank you. The maximum number of zeros of f is 6. 6, right? At the most, the maximum number of zeros is 6. That is the relationship between the degree and the number of x-intercept, right? You see, this polynomial can have 5 zeros, or can have 3 zeros, or 2 zeros, or 1 zero, but at the most, it is 6. It cannot exceed 6. Okay. So now we have local maximum, local minimum. We're going to try to count them. So for instance, this one right here, if you look at this polynomial right here, how many local maximum do you see? How many? 1, 2.
2.
You have
Yeah.
2 local maximum. How many local min you see?
2.
2.
1, 2. 2 local min. Which is a total of 4 local extremum, right? 4 local extrema. Okay, so what it does tell you about the degree? If you have 4 local extrema, the number of local extremum at the most is 1 less the degree. At the most. For instance, just to give you a live example, when you graph a parabola, when you graph f of x equal x squared, right? This is a parabola, right? How many extremum do you see? How many? You see ax squared plus bx plus c. How many x squared are you going to see? Only 1, right?
1.
What is the degree? 2. You see, if the degree is 2, at the most you're going to have one local extremum if the degree is 2. Okay? If the degree is 3, at the most you're going to have 2 local extremum. If the degree is 5, at the most you're going to have 4 local extremum, right? So the number of local extremum at the most, number of local extremum is less than or equal to 1 less the degree, right? At the most is 1 less the degree. That is for more theory, okay? These questions, they are for more theory than everything. And in 163, we don't do a lot of theory, okay? But this is just if in case we ask you about it. For instance, what can we ask you about this? I will not ask this on the test, but we never know. On the exam or something like that. For instance, you have this right here. How many local extremum do you see? How many total?
5.
turning points. I
5.
see 1 here, 2 here, 3, 4, 5. If you have 5 local extremum, at least the degree is 6. Thank you very much. At least the degree is 6, not 5, but 6. Okay. Again, this is more for the theory than everything. Okay. But you know, I will just ask about that on the test. But for you on the test, please, you know, I really am pleading for you guys, with you guys, please know how to graph a polynomial like that, right? Please know how to graph a polynomial like this, okay? It's gonna be on the test. It's very easy if you do practice that, because we don't have a lot of calculations, you see? Minimum of calculation, very minimum. It's very easy if you practice that. If you miss a class or you never seen it, there is no way you can do it, right? Absolutely no way. If you miss the class or you know, or you don't practice enough, come the day of the test, you won't be able to do it, believe me. Okay? But if you do practice enough, then it's going to be easy. You know, very easy to do. All right. So that is for graphing polynomials. So we're gonna start this section 3.3. It will not be on the test because you know I don't want to start the test with a lot of material, which is division of polynomials. Okay, this one will have some calculations, right? So basically, we're gonna do what we call the Euclidean division, right? You know, not the division that we use with the calculators. You know, the regular division. For instance, if you do, you know, I don't know, if you do like you know, 361 divided by 12, right? Do you recall this type of division? Unfortunately, nowadays we don't use we always use calculators, right? But you know, the first time we learn division, you know, we do that. The 361 is called the dividend, right? This one is called the divisor. By the way, this setup, from country to country, this setup can change, right? I guess in the US, we set it up this way. When I was a kid and I learned it in my country, it was this way rather. It was, 361 and here 12, okay? And it changed from, from place to place, okay? But it is done the same way. So process is the same, but the setup, the initial setup can be different, okay? So right here, what you do, we take 12, right here, we take two numbers, enough numbers to include 12. How many times 12 go? I mean, let me change, let me do 14, I'm sorry, let me do 14. How many times 14 goes into 12? I mean, it's 36 is one time, right? Or two times, I'm sorry, two times. So 2 times 14 is 28, we put 28 here, we put a 0 here, and we subtract, we get, 8 here, 0 and 1, right? 81, okay? Is this time to stop? We have to keep going, right?
Because
how many times 14 goes into is 5 times, right? And 5 times 14 is 70. We put this minus, we get 11. So that is a remainder. And this is a quotient. Do you recall that?
Yeah.
Yeah, this is how we used to write. And we write 361 divided by 14 is equal to 25 plus 11 over 14. This is how we summarize it, right? Or another way to summarize is all, we say 361 is equal to 14 times 25 plus 11. This is exactly the same thing, okay? This way is more telling because this way tells you exactly who is the divisor, right? So we're going to do the same with the polynomials. We're going to do absolutely the same thing with the polynomials, right? Okay, the only difference is when it comes to polynomials, it will have some variables. So divide. We're going to see our first example, and we're going to stop right here for today. Divide 6x cubed minus 5x squared minus 3 by 3x plus 2. So this is a dividend. This is a divisor. Okay, we're going to set it up the same way. We're going to do this, open up our half rectangle like this. And here we're going to put the dividend. Now, something very important. Look, I'm going to put in the decreasing order, this from the highest exponent to the lowest exponent, right? And when it comes here, do you see some power that is missing in the dividend? What power of x is missing?
X.
The x, the power 1, right? If it is missing, just to organize myself, I can put 0x. Just to be very organized. Is it mandatory? It is not mandatory. But is this helpful? It is very, very helpful, right? To avoid mistakes, okay? Minus 3. And I'm going to write the divisor in the decreasing order also. 3x plus 2. Decreasing order, decreasing order. Okay? Now what am I going to do? I'm going to divide the leading term by leading terms. This I'm going to do. I'm going to divide leading terms by leading term every time. So what is the leading term is the dividend? Is 6x cubed, right? I'm going to divide 6x cubed by 3x. How much is that? How much is 6x cubed by 3x?
Squared.
2 what?
2x squared.
2x squared.
2x squared. Thank you very much. What am I going to do? I'm going to distribute exactly how we deal with the number. You see, every time you got a number, you're going to multiply by the divisor, right? When we got 2, we multiply by 2 by 14, and we said 28. We're going to do the same thing. But except here, we have to distribute. We're going to distribute here and here, and we're going to put it down here, okay? So 2x squared times 3x is 6x cubed. They're always going to match, right? And 2x squared times 2 is plus 4x squared. What I'm going to do, I'm going to minus that. I'm going to subtract them. Everybody see that? When you subtract them, these two gone, right? So these two gone right here. How much left here? I avoid a mistake. Tell me when you subtract.
Negative x squared.
Is it negative x squared? Look again.
Or negative 1?
Is negative 5x squared minus 4x squared.
Oh, minus negative 9x squared.
Exactly, negative 9x squared. And then I'm going to drop these two. I'm going to drop them here. Minus 3, I'm going to drop them here, right? Everybody see that? And then, do we stop? We don't stop until we cannot divide anymore. Until the degree of the divisor is bigger than the degree of what I have here. Negative 9x squared and then 3x. And I divide. You see, I take this one. I'm going to divide by this one right here. I'm going to negative 9x squared divided by 3x. How much is that?
3x.
Negative 3x, right? Everybody see that? I'm going to do the same thing. Distribute negative 3x to the 3x plus 2, right? So when I do that, I get what? I get negative 3x times 3x is negative 3x squared, negative 9x squared, right? And negative 3x times 2 is negative 6x. And then it's a minus. I'm going to do this, right? Do you see now what is the purpose of adding 0x? Do you see now?
Yeah.
Because when you put 0x, everybody is the same column, right? Each degree is in one column. That is very helpful. These two cancel out, of course, because the reason we did that is for them to cancel out. And then I avoid mistakes. This is x, 0x minus is going to be 6x. Thank you very much. 6x minus 3, right? So what I'm going to do, I don't stop yet because we can divide 6x by 3x.
2, which is positive.
Is 2. Thank you very much. That's going to be my last one, 2 here. And then I multiply. So 2 times 3 is 6x. And 2 times 2 is 4, right? Minus, what I get? -3, these two cancel out, and then I get -7, right? Now I stop. This is the remainder. And this is a quotient right here. You see? So how I summarize my division? I say 6x cubed minus 5x squared plus minus 3 over 3x plus 2 is equal to the quotient is 2x squared minus 3x plus 2. 2x squared minus 3x plus 2 plus the remainder over 3x plus 2. So that is the quotient, and that is the remainder. That is a long division, okay? We call that long division, right? That is a long division. Okay? That is how we divide polynomials. All right. So this will not be on the test. When you come back Thursday, we're going to continue on that. We're going to practice one more example of long division, but we want to focus more on what you call the synthetic division. This is another division, right? Another particular way to divide. We're going to focus more on that division rather than this one, because we're going to use that division, synthetic division, to get zeros, right? The goal of this chapter is how to find the zeros of polynomials. You understand? You see, if I do this right here, if I do f of x equal to x times, x minus 2, x plus 2. I mean, no, x minus 2, x plus 2, x minus 1. Is it easy to find the zeros? What are the zeros?
2, -1, and 1.
Exactly. The zeros are very easy to find, 2, -2, and 1. But if I do this, let me do my math. If I say this is x squared minus 4 times x plus minus 1, the x cubed, minus x squared minus 4x plus 4. Okay, so if I do this, if I do f of x is equal to x cubed minus x squared minus 4x plus 4. And I ask what are the zeros? This is the same polynomial, right? It is the same one. But if I ask you what are zeros, which case is harder? If you are given x, that's in the first case or in the second case?
Second.
Second case is way harder, right? The first case, the zeros are obvious. They are obvious. You just read them. The second case, you have to do something. You have to do some steps, right? Our goal in this chapter is to find the zeros when the polynomial is given this way, okay? So basically, we have to go from scratch to factor the polynomial. And that's what you're going to see in this chapter. It's very important, right? Is if you do math, it's very important to know if you keep doing math, okay? So that process is very, very important. So we're going to stop right here. I would advise you to prepare for the test next week. Just knowing the test. This test, as you're going to see in the review sheet, I mean, it can be a cool test, okay? It can be it can be. You have just to review for it, right? If you need help, you catch me with my office hours, okay? All right, thank you very much, everybody.
Is the long division on the test too?
No. What we did today is not in the test,
All right.
okay? The test stopped at graphing the polynomial.
So what we did with the turning points and the
Yes.
that's
You
fine.
will have a graphing question, how to
Right.
graph a polynomial,
Right,
which is
right.
also on the review. All right, everybody.